Good morning, everyone. Welcome to the webinar. Kindly let me know if you can hear me properly in the chat box. Kindly type yes if I am audible. Thank you so much for the validation. We will be starting off in just 2 minutes. Hello. Good morning, everyone. Hope you all are doing well. Thank you for joining the webinar. My name is Shivani Singh. I am currently working as a techno-commercial engineer at Midas IT Delhi branch. Today, I will be facilitating this seminar. I would like to request our expert speaker, Engineer Chetan Agrawal sir, to give a brief recap about yesterday's session so that any new attendee who have joined today will have some understanding. Over to you, sir.
Hello. Uh, uh, can you listen to me? Am I audible?
Yes, sir.
Okay, that's fine. Can you see my screen also?
Yes, sir.
Okay, that's good. So welcome you all to this session of the webinar. So I'll just have a brief recap what we had done yesterday. Okay. So this was the work. This was the modeling we did yesterday. So we modeled the right side inner block. Okay, along along with the some part more modeling of this earthen dam block also. Then we had modeled the excavation also. Okay, so for excavation, I had used this wedge tool available in Midas FEA-NX, and then I had extracted that volume of the excavation. Then we had fixed the bottom level of the inner block on the right side based on the rock line, bedding rock plane, and 8 blocks we had considered on the right side, 8 inner blocks, so that I mean to optimize our concrete and to have that what earthen dam. Okay, so based on the rock profile as well as NSL, we had fixed up the extent of NA block on the right side. Then, so this is the modeling of earthen dam. I had considered 2.5 horizontal to 1 vertical slope on upstream and downstream of the earthen dam. So we had modeled this earthen dam along with the clay core, presuming that this earthen dam will be clay cored. Internal core will be of clay here, impervious internal core. So that we had considered. We modeled the clay core, then riprap on the upstream side, 600 thick riprap we had modeled. Okay, and then we had modeled the filters, upstream and downstream filters, considering that it may be required because of the size variation of the clay material and the shell material. Uh, so this was a brief recap of what we had done yesterday. So uh, uh, over to you from Midas. I mean over to you, Midas. So please broadcast today's webinar. Okay, this is it from my side for this
Okay.
brief recap. Yeah, yes, thank you.
We will now start with today's session. Let me broadcast my screen. Sincere apologies. Kindly let me sort.
Off. What is this? So, welcome you all to this session of webinar. So, it is in continuation with the series of webinar on dam modeling. So, I'll start from where I left the earlier session. So, we have modeled this earthen dam also, but I should boolean this first. Apply this clay core, apply, what else? Okay, let's keep it as it is. Then create another mesh set for this earthen dam. Let's put it off. What is this? This should also be in earthen dam. Okay, and I don't think I'll need it anymore. Just remove it. On this volume, it has been changed. So I'll remove this one also. And this one, this actually, I should correct it. That would be better. For that, I'll open this non-overflow block also and extrude these faces vertically first. One upstream side also. Some arbitrary large distance. Okay. Okay. And okay, I'll boolean this. I can rotate this. cut. Okay, it will look something like this. Here also extrude normal. Look something like this, and other thing, let's keep it as it is. Okay, where is the earthen dam? This is the earthen dam. Okay, so this is all extra, so I can boolean cut this with this first. This, this. Hmm. This one is only left. I could have used divide tool also. Anyways, now I have done it. That would be easier. Delete this. Okay, and this is still pending. Need to cut it from the center block also, and from the overflow block also. Okay, boolean cut this by this. Test, test, test. Okay, I think this should work fine. Okay, so let's see how our geometry looks like. I don't need any line. Let's keep this. Okay, still left side I have not prepared. I have not modeled. I have to model left side also. So this will be the earthen dam. This will be the inner block, and these are the overflow blocks. Now I can model the left side inner block. Okay, for this, select this one. Extract this. Okay, translate. Translate, no, extrude it. I should delete this surface. I don't need this surface, and then can extrude this along this direction. That would be better. These boxes I don't need anymore. And this is the what you call rock line. Okay. Cut. Finish this and then block this side at this location. Don't need beyond this. That should divide. Keep it as it is. I think I did a mistake this side also. Should start from here at the bottom. Okay, no worries. For that, boolean. Five meters on this side and change my work plane. Okay. Okay, and change work plane to XY. And now I can have joints after 20 meters, say.
Let's keep it because its orientation is different. How much was that? 3.96. Okay, I'll rotate it. That was 3.969490 minus. Okay. Okay. 10 meters here already done. Oh, wrong here. Be here. No, why it is happening actually. Let's keep it as it is. So 20 meters translate. Maybe one more. So we have these blocks. And this block are. No, it's not correct. Sorry. It has to move 10 meters this side. Sometimes you start committing mistakes. Then you can't stop those mistakes even after being so careful also. And yes, let's do, yeah. No, it looks to be correct. Divide this. Okay. these are one block. This is one block of 20 meter and those are 20 meter. So this looks to be fine now. And see, it's almost flat. We can keep these NI blocks as it is. It's okay. This I think I should change it. Mirror this. It's perfectly fitting well here. No issues. Okay. Okay. So now we have to model what you call earthen dam. Yes, downstream filter, and you have to take our clay core to the rock. I think first we should correct the excavation on left bank. Then I'll go to earthen dam. So same thing what I did on the right bank, I'll repeat here on the left bank. So it's almost flat actually, so I'm not providing any horizontal bench here for these NF slopes. Say some arbitrary large distance, say 100 meters. Okay. Just boolean these. We have these two surfaces. Okay. There is topography. Okay. Firstly, I'll need this later on. Height is and boolean cut. Boolean cut. Okay. So at this location, I mean, the rock level is almost up to here, so I have to move this slightly. Anyways, that we can do this later on. Actually, I don't have to do anything here. Just boolean cut these. Okay. This is not a very big, very high slopes here. I mean, very high, 4.74 meter vertical. Okay, I mean temporary, it can be managed. Here also it can be managed probably. And okay, we'll move it to non-overflow block. Later on I'll do that if required. I mean, I'll take my founding level of these Xenova blocks to the ground level, slightly below the ground level later on. Okay, let me finish this work first. Include this with okay. So there will be overflow block here and like this. Okay, I have to now imprint this. Okay, otherwise I can cut this now. Boolean cut. Cut these. Keep it. Okay, so now we have this clay core profile, and this is the downstream profile. Okay, so I need the horizontal filter, say 1.5 meter high. Okay, and I need horizontal filter. So for that, I'll create one line here. Imprint it. This I can extrude in vertical direction by 1.5 meters for horizontal filter. Okay, so this is horizontal filter. Take it to the earthen dam. Okay, then this we need to take it to the rock line. So extrude this internal clay core. Now here we have our impervious, what you call concrete core. So only this portion I have to take it to the rock. Say some arbitrary large distance, 55. Okay, hide it. Don't need this. And this is the rock line. Okay. Move it slightly. Towards this side. Okay. I'll do while it's not crossing this, so better I should extrude these solids downwards. some arbitrary large distance 100. Okay, Boolean cut this. Okay, this and this is left. So, okay, so this will be the clay core, and what is this? Extrude it. Let's remove this one also. Okay, this is very wide. I don't think we need that wide clay core. So probably what I'll do, I'll arbitrarily create one line. No, I'll use this 2D polyline. Somewhere here. Somewhere here. Let's have clay core up to here. Okay, and some arbitrary large distance, and I'll extract this. Extract the faces. Not this one. Don't need this surface. Delete this solid. I'll cut that. Divide this. This can be a clay core. Still, it is wide. I can chamfer it. Probably. Let's try to chamfer it. If I can chamfer it, let's see. Can I chamfer it? Sorry. This is about 8-9 meters. So say 5 meters. 4 meters. Will it work? Yes, say 6 meters. Let it be 6 meters, or otherwise 9 meters. Even 9 meters it works. Apply. This edge. Apply. Probably this edge. Apply. Okay, let's keep it. This much of clay is required. Let's see earthen dam. This is, and we have this filter on downstream side also. Okay, probably we can merge these two filters. Boolean merge. These are downstream filters, and I can even cut this shell, this filter. What is this? Okay, this is clay core. This shell. This filter. Okay, now the layer is clear. This is shell and this is the filter, downstream horizontal filter. So section will look something like this. It seems to be okay. Riprap on the upstream side, shell here, filter here, clay core here. Maybe we may need, somewhat steeper slope of clay core, but that will depend on design. At the moment, I have considered 1:1 slope. and then the clay core needs to go up to the rock. Probably from here I can have. Okay, let's keep it as it is for now. Okay, so it's fine. Don't need this. I think I can now delete this. No, I mean some minor modifications are still required, some fine tuning. I don't think this is advisable. So high straight wall for this pier. HM vendor will require access to it. He can have steel ladders installed here, but this is not okay. For that, what I'll do is Boolean cut. Do this. I think this should be somewhat better. Okay, otherwise I can have a step here. Okay, let's keep it. This should be better. I mean, and vendor can have a steel ladder here, and from here he can go up to this trunnion beam and even to the hoist location, and probably we can have power pack room at the top of the pier here, or if I mean, it all depends on the HM design. So let's keep it as it is. Translate this, copy 2 points. So translate these 29 times, 15.35 meters now. Okay, so this is somewhat better. Okay, don't need earthen dam. Height. This is also okay. These are all fine. I'll include everything. This first block. That's that. Okay, let's correct this and I block also. Extrude. Colors are fine. Oh, yes. Okay. Probably this solids. It's all correct. Okay. No, I think it's fine. Okay, let's keep this session up to this point only. So in next session, we'll meet and we'll conclude the modeling part of the time, whatever is left. Galleries are left, and then staircase and lift well. Those we'll model in next session.
Okay, so thank you so much to all attendees for attending the webinar. Just before we conclude, Chetan sir, would you like to add on something? I'll just give me a sec, sir. Okay, I guess Chetan sir is there. Okay, so thank you so much, everyone, for attending this session, and have a good day ahead. If you have yeah, any questions, you can get back to us via the email, right? So there's a workflow open. There's a question which I would like to, answer, I guess. Is it possible to, okay, two of the questions I can see. So is it possible to model 3D model from AutoCAD or any other 3D software modeling after import to MEDAS NX, FENX for generating mesh and begin calculation, analysis, and design? Okay, and the second question is, just a sec. Yeah, there is a workflow open BIM between MEDAS, FENX. So the main question is, I can figure it out right now. That is, the integration between the softwares, right? So yes, the integration of the software can be done, and what all other softwares or other softwares, meaning including the MEDAS software packages and the other softwares, what all can be imported and exported. We'll definitely address it in a yeah, we'll get back to you in a particular email, or we can discuss before the commencement of the next session. So you guys don't have to worry about it, right? So yeah, any other specific question, you can get back to us on the email. So yeah, thank you so much for attending the webinar and have a good day ahead, please.
So this was the end of our third presentation. So I believe we have a couple of questions which I would definitely like to share with Chetan sir, and we'll request him if he can, give us a prompt response. It seems like because of some time issue, Chetan sir has requested us to send the question over an email. So to users who have requested their questions, we'll be definitely sending them an email reply to their respective questions, sir. So thank you so much, attendees, for joining in this third session. And I'm expecting you to present tomorrow in our last session of modeling. After that, we are going to proceed ahead with the analysis and load applications on NOF blocks. So thank you so much, everyone. Thank you so much for your time. Hoping to see you tomorrow. Same time.